Well, good morning, everyone. I'd like to welcome you to Grand Rounds. So we are really honored today to have as our speaker Professor Martin Elliott from London, United Kingdom. Professor Elliott is the 37th Professor of Physics at Gresham College in the United Kingdom. This is a highly prestigious position. It is a position that really helps to focus the government and individuals throughout the UK on matters of importance in healthcare, and he has been playing this role over the last year or so. Going back to the beginning, Martin is originally from the Midlands, from the Peaks District in England, a beautiful area where I was lucky enough to spend time as a medical student. And then he went up to Newcastle, up in the north, to medical school. He stayed on there and did his cardiothoracic training at Newcastle. This was an extremely busy time for coronary artery surgery. It was exactly the same time that I was training in Australia and New Zealand, and there was a lot of coronary artery surgery going on in those days. From there, he went down to London to Great Ormond Street, which then and today remains one of the leading centers in congenital heart surgery in the world. It's been a leading center in developing new techniques, and probably just as importantly, it's been an incredibly important center for educating young congenital heart surgeons from around the world, particularly from the United States. And if you actually look at leaders in congenital surgery in the United States today, many, many of them spent time at Great Ormond Street learning congenital cardiac surgery, and the person who was doing much of that teaching was Professor Martin Elliott. So he was an outstanding educator at Great Ormond Street after he came on staff there as a cardiothoracic surgeon in 1984. He also introduced a lot of innovative surgical techniques in the field of congenital heart surgery, but he's probably best known for his development of tracheal surgery in small babies and young children, including innovations like implanting tracheal homografts into kids with particularly challenging tracheal problems. In addition to his surgical innovations, he's had a very long-standing interest in quality assurance and has played a very, very important role in the United Kingdom. There have been a lot of challenges in the United Kingdom with a nationalized health system as to the number of congenital heart programs. And if you're going to rationalize the number of congenital heart programs, how do you choose which programs should remain open and which programs should close? And that really requires some very sophisticated method for assessing outcomes at different programs. And he's really been an extremely important force in the United Kingdom in terms of analysis of outcomes and quality assurance for congenital heart surgery, and most importantly, for transparency of those outcomes to the public. And the United Kingdom is really light years ahead of us in allowing the public to have a very good understanding of what outcomes are like at different programs, so they can choose the program that they wish to move to. And he talked to the cardiac program yesterday afternoon. The title of his talk was essentially truth, the importance of truth and transparency in releasing outcomes. But today he's focusing on a different topic. As I said, as Gresham lecturer, he plays an important role in defining healthcare in the UK, and there are areas other than truth, and today the focus is on lies. Lies in medical publishing and how medical publishing can be manipulated by whomever. So Martin, it's certainly a great honor to welcome you here. Martin's been a good friend for many, many years. Martin, thank you.
Thank you very much. After that, I'm beginning to wonder what I'm going to talk about. So, thank you for that very kind introduction. This is something I probably want you to remember during the talk. We always start to look at stuff too late. Now, the grasshopper that you might see faintly in the background is the Gresham College symbol, so you need to see that. But I wanted to talk about lies, seeing through the lies, because I've, as you've heard, been involved in surgical innovation, as so many of you have. And I was extremely surprised to be involved in something that went pear-shaped. So, are you sitting comfortably? Because I'm going to tell you a story. And it's a story about this young man who's called Kieran and his amazing mother, Colleen, and I'll explain why he's amazing. Kieran has always been in the first 10 of any procedure he's ever had in the world. So he's like a living experiment, and his family have had to give the most complex consent of almost anyone I've looked after in my life. He was born with long segment congenital tracheal stenosis. He had a 1 millimeter trachea. He couldn't breathe when he was born and was put on ECMO in another hospital and transferred to us. And he was the last person who I did a pericardial patch tracheoplasty, which is like widening your trousers. I'm getting older and fatter, and that happens often. As a cardiac surgeon, the only bit of the anatomy I knew anything about was the heart, and it's wrapped in this stuff called pericardium that you can use. And the problem with it is, this is from that operation when he was very small, I took a patch of pericardium and repaired his trachea with it. It's thin, it's easy to use, but over time it shrinks and it scars and then blocks the trachea. But it was a very useful operation. We did it a lot in the 80s and 90s. But it scarred, and he needed a stent. And in those days, the only stents we had were Palmer's metal stents, and he was one of the first 10 people in the world to have one. That's him, with his stent in place. And he did well for 3 years. And then when we put a stent like that in, you kind of have to remember that there's anatomy involved, and we, not being very bright, forgot that lying over the front of the trachea is something called the aorta, which carries quite a lot of blood, apparently. And his stent eroded into his aorta, and his mother astonishingly resuscitated him as he was coughing up his aortic blood. She somehow let his blood pressure drop and was sensible enough to keep him very quiet. And so I had to put something on to repair his aorta, patch his aorta, but his trachea was a mess where it had eroded. I had to cut away that much, so 5 centimeters of trachea, and patched it with this, which is tracheal homograft, human trachea pickled. And it was pickled in formaldehyde, methylate, and stored in acetone. So it was essentially stripped of all viable tissue and was something like a collagen matrix. And we'd used it for patches. This is the longest ever used in a human. Now, we'd used this in 33 children at around that era, and there had only been 2 late deaths. I did this with Jeff Jacobs, largely from St. Petersburg in Florida, and Klaus Herberholz, who's an ENT surgeon from Bonn. And we peripatetically did these around the world when somebody got into trouble. We used to take them through customs, which is interesting. And actually, just to go back to that graph, the results weren't bad, considering everybody we put this into was making a good effort to die. At the age of 12, now this is like a decade or so after we'd done that operation, his stent eroded into the aorta. You can see the metal stent, and you can see, we had another one by then, eroded into the aorta. You can just see the clots on the inside of the trachea. The homograft that we were using was no longer available because of BSE. Do you remember bovine somatotrophic encephalopathy and prions? And we hadn't been able to, we never looked to see if there were prions in there. We hadn't known about them. But anyway, it went off the market or off research use. And so we had to look around for something else to do because he was trying to die. He was being sedated in an intensive care unit in Belfast, trying to bleed every day. And only by keeping his blood pressure down and sedated was he alive. But he needed, it's only a tube that carries air. We ought to be able to do something. So about a few weeks before this had happened, our team, which had been involved in trying to build tracheas in the lab using tissue engineering techniques, and working with Paolo Macchiarini, who was worked in Florence, Paris, Bonn, and at this time was in Barcelona, and had developed a technique where you took donor cells, donor trachea, stripped the cells from those, and replaced them with mesenchymal stem cells from the recipient, letting them grow in a bioreactor until you could replace a bit of trachea. And she actually had the origin of the left main bronchus from an old TB injury, which was occluded, and he replaced, with the help of teams from all over Europe, her bit of trachea using this technique, and she did well. And Claudia's still alive. She's a very nice lady. She's had a pneumonectomy since, but she's still alive. And that's Paolo. And my colleagues Martin Birchall, Mark Lardell, and me faded away in the background. We did this operation in March 2010, and we didn't have time to marinate the graft in its bioreactor, so we did something slightly different. What we decided to do was to upregulate his bone marrow by stimulating with erythropoietin and TGF-beta, and then we marinated his graft, the donor graft, on the day of surgery for 4 hours with the stem cells and implanted it with a momentum around it to try and hope that the cells would take. So this is the Armani graft. This comes from northern Italy. It's very beautiful. And it was a human donor, measured exactly to what he needed, which was 7 centimeters of trachea replaced, the whole trachea, chop the ends out. It took me 4 hours to remove his trachea. And during that time, this graft was marinated in the cells at the manufacturing facility we have at the Royal Free Hospital and brought back by motorbike by the time I'd finished the insertion. And it was the first stem cell supported graft in a child, longest one, and the first absorbable stent used in the trachea in a child. We had those developed in first stem cell, first stent. Here he is again. Each one of these has a different consent process. It was 37 ethics committees to do that, by the way. He lived after a torrid first few weeks and did very well. He became the Irish Child of Courage in 2012, went to see the Pope, and met all the big stem cell Nobel Prize winners that year in the Vatican. Had a nice year. And he went back to his day. He's a much better drummer than I am photographer, and but it was a good party, and he's still drumming. He's driving a tractor and working on a farm. Now, it wasn't cheap. For convenience, I put dollars and pounds on both sides. You're the yellow one, and it cost an awful lot of money in the first year. Maybe not a lot of money, actually, looking at the bills of some of the people in the ICU. But over the next 4 years, it's cost virtually nothing. He's on no drugs. He's grown, he's now 168 centimeters. He's put weight on. And he has a quality of life score of 50, which is better than heart transplants. Right? Is that good or bad? I leave you to decide. And this is a biopsy from his middle of his trachea last year, showing the cilial function. at real and slow speed. His cilia are working, pumping sputum north. I have no idea, absolutely no idea, whether these are his cells that have grown in from the edges, or these are our cells that have become epithelium. That's a piece of research we have to do. Now, while all this had been going on, we thought, why are we wasting time collecting donor organs when we might be able to use the microarchitecture of the trachea and build a nano-based material which has that similar architecture, and then we can marinate on a plastic, or similar to a plastic, the cells in a bioreactor lab. And so we did that, and you can, but they don't stick very well. So we decided that wasn't suitable for clinical use. We tried it in a few animals, and it was just not good enough. So it's there. We're still working on materials, but we gave it up. Paolo, on the other hand, approached a company in Boston, not with our technique, with a slightly different one, and had some made. And moved to Karolinska in Sweden. And he got a grant, unusually from the Russian government. Is anybody from Russia here? I have to be careful what I say. He got a grant from the Russian government. Actually, it doesn't matter in this country, does it? Come to think of it, especially in this town. Anyway, so he got a grant from the Russian government to do tracheal replacement using this nanotechnology material. And he did his first one in Prioria, actually, in this country, and then he did peripatetically around Russia and some centers in Europe this operation. Peripatetically. Go in, be the great surgeon, come home again, leave the recovery afterwards. Then the story gets interesting. So far it's just science, sort of. Paolo gets accused of fraud in Italy for charging people to go into private practice to have their operation rather than use the state system. He is questioned about his consent methods in all of these peripatetic operations because he just turned up to do the operation and said it was going to work. I mean, I paraphrase. And then the community who did tracheal surgery around the world started to feel that the data and the outcomes he was talking about didn't actually ring true, didn't seem right. And then the best bit, we start to have a story, which you might remember, of a great film by Steven Soderbergh, Sex, Lies, and Videotape. Okay, and guess where I'm going to start? We come back to America, because Paolo is unbelievably handsome and charismatic, and everywhere he goes, people fall at his feet, usually of a particular sex, I may say. He is very charismatic and very Italian. And NBC wanted to make a documentary about him. And so they flew him from Europe to the Boston Mandarin Oriental, put him in the presidential suite, and met him in the bar with this lady, Benita Alexander, not on the cover. Benita Alexander is a prize-winning producer, some of you may know. And I'm using this with her permission, by the way. So, and all of this is in the public domain, so don't think I'm being indiscreet. I am being indiscreet. They planned a 2-hour documentary, and they got on really well planning this documentary. In fact, so well that they spent the next year or so getting to know each other somewhat better across Europe. As she said, it was really good. It was so good, they decided to get married. He proposed to her, and he'd operated on Putin, he'd operated on the Pope, and he'd operated on somebody who was to do with the Clintons, but we didn't know what. Anyway, this wedding was big. It was going to be in Castel Gandolfo because the Pope said he could get married in the Summer Palace in Italy. Eventually, he said that, extremely unusually, he would officiate at the wedding, and they started to send out invitations in white kid leather boxes, as you can see, with very little inhibition about who the invitations went to. This was set up for October. Now, Benita worked at NBC News, and she invited all the NBC News people to go to it, including, I think, the religious affairs correspondent, who said, Benita, I think there's a small problem. The Pope is doing a tour of Latin America on the same day as your wedding. And it was demonstrated to be, as the lawyers in England would say, a tissue of lies from beginning to end. There was no truth in any of the story. He had a family in Tuscany. He had some sort of family in Barcelona. And he had this relationship with Benita all over the world. And no wedding, and no Pope, and no Casa del Altar. Other things started to emerge. This is a surgeon from Leuven in Brussels who was also interested in fixing the trachea. And he used a completely different technique of putting the trachea upside down in the forearm, inducing tolerance with half-dose anti-rejection therapy, leaving it there for a few months, transplanting buccal mucosa to the trachea, and then doing the tracheal transplant. Really suitable for bigger people, but he did some. And he said, this is going to work. All stem cell regenerative medicine of hollow organs is bullshit. And I don't believe any of it. It's all lies. And the people who do it are black magicians. So I called a meeting together with Dan Weiss from this country to see if we could pull together everybody in the field, and we had a meeting in Paris. Macchiarini refused to come. And Pierre Delaire said, he eventually came, but was the sort of sullen guy in the back row. I don't like all these people. What are them? Why am I here? It was a difficult meeting, but we did publish a consensus statement about what needed to be done in the science, recognizing that we'd only played around at the edges of survival for compassionate use. Now comes the videotape, sex live videotape. His charisma was attracting documentary makers from all over the world. And this is, I must say, one of the best journalists I have ever met. If you ever get the chance to look his name up, Bo Lundqvist, apart from being good company, he will get you to talk about anything. And you just realize that good journalists just don't need to be aggressive. They just need to talk to you. And all your truths come out. And he made a fantastic documentary which went out live on Swedish television for 3 successive evenings during prime-time viewing. And he had followed Macchiarini around these peripatetic operations. And he read all the papers in detail. And I'm just letting you, these words come up on the screen. You get the idea. These are from the paper. He writes that the grafts were getting new blood vessels, were covered with a well-developed mucosa, vascularized, and everything looked good. But what was clever about Bo, he actually decided, he kept asking, now look at the histology. Would you mind awfully if I saw the video of the bronchoscopy? And like most surgeons, you get flattered. Oh, yes, please. Delighted. Come and have a look. And this is what went out live on Swedish television, the bronchoscopy of a patient in the paper who had perfect vascular lining of this plastic graft and no stent. So what you see is no vascular lining, no blood supply, a stent, and actually at the distal end of fistula. Same patient that was published as a good result. The videotape, this was just one of many, demonstrated that what was in the paper was not true. Macchiarini was fired and sued, and still lots going on. He was being accused, actually, in Sweden of something which is like second-degree murder over here, manslaughter in the UK, murder by negligence. It hasn't actually been filed, but the lawyers are busy looking this way. He's now professor of surgery in Kazakhstan. Gets out of the country. But I want to talk about the collateral damage and what this means to us as a scientific community. Because not only was he fired, but the Vice Chancellor of Karolinska University, the head of surgery, the head of ENT surgery, gone for appointing him. And in London, where we have a big regenerative medicine lab, UCL stopped our grants. Didn't take the money away, just stopped us using the money. And they've had a one-year inquiry into everything we've done, and specifically our contact with him. We were unable to get grants during that period. This is Paolo Di Coppi, who is originally from Padova, a brilliant pediatric general surgeon, and who leads the regenerative lab in my hospital. And I interviewed him to see what he thought about this.
You said earlier on you were angry.
Yeah.
How has this whole thing affected your life?
Well, it's very interesting because there are about 35 people in my lab at the moment, and the first thing I heard from the postdoc, they are working on this, and so they were really pissed off with the fact that they saw what they've been working for 5, 10 years, and their passion and all their future and all what they believe to be useful one day for patients may be destroyed by the fact that things are not being done properly. And
things are not being done properly. This is Martin Birchall, my other co-worker, an ENT surgeon with an interest in stem cell biology, and he talks about this relationship with Macchiarini in a much more personal way.
I was very useful. I felt more that I was useful to him than actually a true collaborator or a friend.
He had this power of personality which it's very difficult to describe if you haven't met him. He was a force of nature in a room, physically dominant, a wonderful companion at dinner, expert in wine, I think, and we used to enjoy his company. Well, surely Paolo is a one-off. Well, sadly, doctors have a narrow view of the world, usually, and some doctors lie, I'm sorry to tell you. We have, keep calm and trust me, I'm a doctor. The relationship of trust we have with our patients is very strong, but I would argue that over the centuries we have let that trust down really rather badly. You only have to go to the 23 doctors at Nuremberg to realize how badly such trust can be eroded. And there's a great book by Roy Porter called Quakers, Fakers, and Charlatans in Medicine, which draws attention to the fact that our world was and is full of charlatans. You only have to, we were talking about this at breakfast, to discover the power of blueberries to understand how many doctors can make their career on a dietary fad. MMR, that Andrew Wakefield, a British doctor, who was paid for by a drug company, made up the results, and whose impact on measles mortality around the world has been huge. Incidentally, he released a film which was withdrawn from Sundance and Toronto, and was supported by a number of current politicians in this country as being a good thing because it was a liberal idea not to immunize people. Bad, fraudulent science and wrong data and bribery and corruption. And much as I'd love to go into the details of all these cases, I'm just going to show you a list of famous cases over the last few years of people who have done the same thing and whose careers and all their co-workers and all their papers have either been destroyed or withdrawn from the literature and the specialties in which they existed. Doctors, people potentially like us. There's a really good abstract published last year from Boston University. And they looked at the surgical papers that had been withdrawn from the literature over a 25-year period. And they come from all specialties, including basic science and anesthesia, and all over the world. Now, I've been in academic medicine for long enough to know that a small sample like that is the tip of an iceberg. These are the people who were found out. They were largely data-related problems that were involved, but some were frankly made up. So, do people lie? It's really, there's many papers on this, but this is the one that sticks in my mind most. they asked 1,000 American adults to report how many lies they'd told in the previous 24 hours, and 60% said they hadn't told any. Anybody here told a lie today? Not best put your hand up, I bet. It's early in the day, there's plenty of time. I'm not drunk, officer. Almost half of all the lies turn out to be told by 5% of subjects. And what happens is that the lies are associated with a few people who are prolific and repeated liars. I'll leave you to think if you can imagine any of those people. Now, I have a moral position over science which has become firmer since these events with Paolo Macchiarini. This is from the Public Library of Science PLOS data. It's our job to publish unbiased and accurate representation of the work we do. Does anybody in the room disagree with that? Okay, we can move on. Because I feel a strong sense of shame about my life in surgery. And the reason is this, and this is where I hope to be a bit more contentious, because the rest is just a story. This is a bit more contentious. I'm going to argue that the current system of medical publishing is out of date and not fit for purpose. It conspires against the proper accumulation, sharing, analysis, and replication of data, and therefore facilitates fraud. I'm not alone in this. There's a group of editors of medical journals around the world who see the relationship, the cozy relationship between the publishing industry, which is a $7.5 billion, 5-company dominated market, as a cozy symbiosis between the universities, who largely buy their journals, and the journals itself. Let me argue this case through. If you do some research, you probably want to publish it in a journal, of which there are 11,000 or more medical journals, 2,500 papers a day, nearly 1 million papers a year, and medical knowledge doubles every 73 days. Try and keep up, by the way. Now, my career has been built on the number of papers I publish, right-hand side, after peer review in a journal. I get brownie points. Do you know what do you have brownie points over here? Right. I get brownie points if I publish my papers in a journal with a high impact factor. Who knows what an impact factor? How do you calculate an impact factor? Tell me what an impact factor. You know how you calculate it? The number of times that journal has been cited in the previous 2 years. And your citation index of your paper is the number of times your paper was cited in that same time period. I didn't know that. I had to look it up. Now, when you're a surgeon, nobody reads what you publish, really. They measure the height of your papers published when you go for the interview. If you can wheel it in a wheelbarrow, you're a good person. Especially if you're an orthopedic surgeon. Because they've got their knuckles off the ground by then. And you have to, my academic promotion and all the research grants I get measure those characteristics. Publish or be damned. Have you heard that phrase before? I certainly have. So here's my argument that I want to go for. When I make up a paper, I actually collect a bunch of data about a set of patients. I own it on a USB stick in the trunk of my car. It shouldn't be there, but it is usually. I've designed the data set myself to collect data, maybe with a few friends. I might have gone through a couple of committees to say that's okay. No, but I have a commitment bias. I actually believe that what I'm doing is good. And I have a conflict of interest because I'm going to get air miles if my research works out. And I have no idea if my data set is comprehensive because I've just thought it up. What gets sent to the journal is nothing to do with the raw data in surgery and in a lot of medicine. It's a précis of what you've done, and a précis of the protocol, and a précis of the data, ending up with bar charts or histograms with a few confidence intervals. The data are not there. The raw data stay at home. And because I'm owning it, it gives me the power to compete, to not collaborate. Collaboration requires a high level of trust. So the risk here is that I will hold this to myself and not share it. And surgeons do that better than most. So I'm actually quite vain because I'm a surgeon. So I'm going to invent a new operation. Here it is. And why am I doing that? Well, I'm convinced that what I want to do for this procedure is right. I've been thinking about it for a decade. I know I want to do this. And I've worked out how I'm going to do it. I also maybe have a narcissistic tendency, but it also might be my academic survival to get more new stuff, to win my brownie point. And so we'll talk together, we'll get ethical clearance, and we'll do a bunch of operations, say the first 10. Now, anybody who's been involved in surgery with a team knows that you talk stuff through until you know what you're going to do. And an awful lot of that is quite intense, deep personal understanding, but quite hard to write down on a piece of paper. You just kind of know when you get the operating room. But you know what you do. The 10 all survive. I'm going to publish the outcome. The outcome's good, and I send it to the journal. The journal likes it because they want to be the first to publish something new. It's good for their reputation to publish new stuff, and they have a positive publication bias for good results. You're familiar with that term. The peer reviewers may be flattered to be asked to review it. They may feel it's their duty. But quite often for an innovation, they're also in at the beginning, and so they want to be the next ones to try it. So the Norwood operation, for example, when the first paper of 3 patients came out, people wanted to do it all over the world. It was how surgeons weighed their cojones. Now, that second wave of operations that were being developed, other people copying my operation, more operations on a separate site, didn't have that kind of knowledge that we had about this operation because I haven't been able to write it down in my 2,000 words. They might ring me up, but they don't always. And the diagrams I'd done were just 10 survivors and the 3 weeks living. But why are they wanting to do it? Well, I may have convinced them it was a good idea, or it may be their academic survival. But very often in the second wave of surgical publications, of operations, Norwood, Switch, I think anybody who's done any new stuff knows that the mortality is much higher. The journal won't take your paper as a result, and maybe you don't want to publish it. They won't take it because it's not new, it's got negative findings, and there's no reputation gain for them to publish that paper. It's really common there. The peer reviewers never get to see it, and so the raw data associated with these patients are lost forever. They live in a USB stick which goes out of date and can no longer be plugged into any computer. Now, our colleagues in other parts of science don't face this. You can't publish a paper on astrophysics without the raw data. You can't publish a paper on statistics in statistical journals without the raw data. And you can't do the same over mathematics without the raw data because they believe, they understand they may not be right. And wouldn't it be nice if you all had a look at these data and see if you can come up with a better way of doing it? Look at the CERN publications. They've published the authors separately from the data. The data is what gives them their brownie points, not the weight of the paper. I looked through the NIH records to see if I could find a place where I could store my data, because we can look at the other scientific questions. There is nowhere for surgery, no raw data. Thanks. So here's my proposal. First, the data sets that you design, and to do, I'm missing out the protocol stage. I'm assuming at this stage that we work out a proper protocol. So the data sets must be well designed in advance. And at that stage, prior to any publication, they should be open to review, criticism, and contribution from the field. So just take another example. If I set out to create my new operation in the cardiac surgical field, it makes sense to ask Richard or Gerald whether I'm asking the right questions, and the patient, not think it up for myself. Get the data definitions absolutely robust, weight in kilograms, whatever it is. The number of definitions of blood pressure in the renal literature is terrifying. The data should be held securely. It should be publicly accessible and have public API. That means that you can share it across different computer systems. Now, I'm going to argue that in another way. So all patients who have an innovative procedure, we need to know some stuff. We need to know the outcome, any adverse events, long-term follow-up, and actually I would add these days the cost, because value equals outcome divided by cost, and that's the only way you're going to get the value equation solved. The data should go to some sort of honest broker, as they do in astrophysics, held neutrally, not owned by me or Washington Children's or Great Ormond Street. And that honest broker can then distribute the data to those people who need it, regulators or hospital trusts, other people to analyze data, and the patients themselves, because that is transparency. And transparency provides trust. Here's where I get totalitarian. I've published my 10 papers. I do not think that any surgeon should be allowed to enter the second wave of operating unless they contract to submit a validated data set to that honest broker in the same data definition. Okay, here, second wave of totalitarianism, prepare yourselves. I don't think that any patient should be allowed to have this innovative and untested and untried procedure unless they agree to use their data in this way. Now that may seem radical, but we share our blood through blood donation voluntarily. If you ask patients, in our experience, people are willing to donate their data to a good cause equally. I think we need to move from a system of fear to one of openness and trust of the patients and share it securely. Now, there's nothing new in this. This comes from the National Academy of Sciences in 2009. You are ultimately responsible for ensuring the integrity of your data. You. It should be publicly accessible, these data. And the data should be stored so that other people can find it and use it accurately and appropriately. Just count up in your head the number of surgical papers over the last 25 years where that might be possible. We've made a decision at UCL and at Great Ormond Street, along with the Gates Foundation and the Wellcome Foundation, that we will no longer, well, we will support, but we don't prefer publication in the conventional journal. Because the Journal of Thoracic and Cardiovascular Surgeons, circulation, won't take the raw data. So we are using this group called F1000, who are committed to taking the data on board. I don't think it's perfect yet myself. There's a long way to go in the mechanisms of this. But as a model, we now, when you start work with us, we say, please publish in this place. And they publish negative results and they publish case reports, but peer review takes place at every stage, protocol, data set, and at review. And all of those reviews are published as well with the author's name. And if they add to the quality of the paper, they become a contributing author. Now, anybody got a big stack full of Bitcoins at home? Anybody know what blockchain is? Right, so those of you who know about blockchain will know that it's basically a ledger. It's a ledger with an audit trail. So that you put the data into a secure place, properly encrypted, and you can audit when there are changes to the data. It seems to me that blockchain may well offer the secret for managing data in this way. So if you can guarantee the robustness of your data at the beginning, you may not be correct with your data set, but at least you know that it had some peer review and you stored it. Then all changes thereafter can be tracked, and if you add patients to the data, you will be able to see when and how it happened. Now, this will not stop Paolo Macchiarini lying about his results. He may still do that. But if now we all try and do the same thing and it doesn't work out, if we put our data in the same place, he will be exposed as a fraud much more quickly than he was. That seems to me to be really important because science is about replication of results. Eventually, it appears to be the truth. Blockchain may well be the secret. I think we've failed as well, and we were just talking about this a few moments ago, to get consistency of data definitions across all the electronic patient records in hospitals. They're different from hospital to hospital. So you can't export your data to Great Ormond Street without employing someone. It's a pain in the ass to manage a registry because these things are not done well. We can change that by breathing down the necks of ethic and CERN on all these companies until they do make a change. And if those data definitions are right at the beginning, then we might be able to slide the patient data into blockchain with secure, secret access. And of course, we have to be able to share it. Now, the moral and ethical framework of medicine is straightforward. We have to be safe, we have to provide a good experience for our patients, and we have to be effective. To do that, we have to tell the truth to each other and to our patients. Otherwise, there's no trust. Trust is the basis of what we do. I would say, you used to say that patients should be protected from liars, but my own experience now is that we need to be protected from liars just as much. And 5% of people are liars. 5% of doctors are likely to be liars. 5% of lawyers, 5% of politicians, 5% of anyone are likely to be serial liars, according to the literature. So instead of pretending it doesn't happen, why don't we assume that it does and find process mechanisms which protect us and the patient from it? I showed this slide yesterday, but it's an important one. Bill Douglas was the first Supreme Court judge to publish their findings openly in this country, and he said sunlight is the best disinfectant. I have nothing to argue with that. So thank you very much for listening. I know it's been contentious. This is Annick Castle in Northumberland, which is the model for Hogwarts. I was there 2 weeks ago. I'm very happy to both to take questions and for anybody to contact me afterwards. Thank you very much indeed.
All right, thank you so much. That was spectacular. So we have questions. I see Gail Pearson is here from the NIH. Gail, do you have any thoughts on potential role of the NIH in being a data repository along these lines?
Who knows about blockchain? A few of us have been starting to think about the potential role of blockchain as a way to harmonize and democratize the data in the 1920 congenital heart disease registries that there are. This could be a potential way for hospitals like this one, who spend a lot of money supporting contributions to various registries, to have de-identified data that's available through this system of contracts and ledgers that people could use as almost in a data commons model. You could request data from several places. You could learn about outcomes. Patients could potentially access the data. I don't know about NIH being the repository, but NIH has a data commons project that they're about to launch. My institute, NHLBI, has a major role in that, and I'm busily arguing for a pediatric piece of that. So I think a lot of things are coming together to suggest that this type of disruptive change in data sharing is possible.
Great talk, Dr. Elliott. Thank you so much. You know, I'm concerned on one aspect of this. I wholly support virtually everything that you said, but the generation of data represents a lot of work, a lot of hard individual sweat equity to generate a data set. And there's a part in me that is a little troubled with the idea that that data set that my group has worked so hard to accumulate will be pushed out almost immediately for public access before I've had my chance to have at it, and to think about all the different ways that I could use that data set to tell stories that will, improve patients' lives. How do you respond to that?
Well, I'm a bit like the NIH. I'm at an early stage in trying to think this through. So I don't have an answer to that question. But I think it's a slightly moral response rather than a factual one. I'm not sure you should own it. I think that's part of the problem. I think the rest of us need to find a way of recognizing your contribution, because that's what you're looking for, is some kind of, I don't mean this personally, but some sort of status-related thing that's related to what you can do with those data, develop it under your own auspices. And I imagine that there are various ownership models that could be done, but I don't think you should be allowed to keep the data to yourself, because that is, it doesn't actually in the end make sense, because that person sitting over there might have a better idea than you do. If you don't show them, you won't know. I think it's challenging, but there'll no doubt be various iterations to play with it. But when we put out, spreadsheets for people to say, is this right? They always come back different and better. Always. And the wider we distribute it, the more interesting the responses are. Very often from patients themselves. So that's not an answer, really. It's all gone quiet. Thank you very much indeed.